Sample problem 22.02. The question is about electric dipole. A vertical electric dipole that has charge minus q at cloud height h and charge plus q at below ground depth h as shown in the figure. If q equal to 200 coulomb and h equal to 6 kilometer, what is the magnitude of dipole's electric field at altitude z1, which is equal to 30 kilometer somewhat above the clouds, and altitude z2, which is equal to 60 kilometer somewhat above the stratosphere? So in this question, we are going to find the electric field due to dipole. So let's see the given figure. What we have in the figure, we have the dipole, because the dipole consists of two charges, positive charge and negative charge. So here from the ground level to the height of h, we have the negative charge, and likewise the positive charge is below the ground level, and this height is also h. So now what we are going to do, we are going to find the electric field due to the dipole at two different heights. So the first height is above the clouds and the second height is above the stratosphere, because the atmosphere are classified into many layers, right? So we have to find the electric dipoles, that means the electric field due to the dipoles to different levels, that means two different distance. So for this question, we have to recall the formula. In theory, we studied electric field due to dipole is given by the rule E equal to 1 over 2 pi epsilon naught P over R cube. We studied this one, right? So here P is the dipole moment, and we can write this dipole moment, the formula for the dipole moment, which is equal to the charge multiplied by the distance. Clear? So here, let's see the distance here. We have the distance between the two charges. So in this place of P, I am going to substitute this formula. So let's see what will be the formula. E equal to, it's a vector quantity. So 1 over 2 pi epsilon naught. When you substitute this one, we will get Q multiplied by D over R cube. Clear? Now, what is this distance D? So the distance D is nothing but from here to here, we have the height h, and likewise here also the distance here is h. So in this place of D, I have to substitute 2h, because from the ground level to negative charge, the height is h. Likewise, from the ground level, that means below the ground level, we have the positive charge, and this height is also h. So total h is nothing but h plus h, which is equal to 2h. So I'm going to substitute this value of the distance here. So what you will get, electric field E vector, which is equal to 1 over 2 pi epsilon naught Q multiplied by 2 times of h over r cube. So here r cube is nothing but the distance. So here in place of r, let's we use the letter z. Okay, so I can write z cube. Now I'm going to use this formula for finding the electric field due to the dipole. So let's we consider the first distance, which is z1, which is equal to 30 kilometer. So I have to use this formula. So electric field, which is equal to, that means better I can use the letter A for the first height and then B for the second height. So E vector, which is equal to 1 over 2 pi epsilon naught Q multiplied by 2h over z1 cube. So here we are just writing for z1, which is 30 kilometer. So 30 kilometer, because we have to convert this kilometer into meter, so we have to multiply by 1000. So now what I'm going to do, I'm going to substitute the value here. So 1 over 2 pi epsilon naught, and then the charge value here they mentioned 200. So in this place of charge, I have to substitute 200 multiplied by 2 multiplied by what is the height, which is 6 kilometer. So I have to convert this kilometer to meter. So 6 multiplied by 1000, which is 10 to the power of 3 over z1, which is 30 kilometers. So again 30 multiplied 10 to the power of 3, the whole cube. So here we got the answer E, which is equal to 1.598 multiply 10 power 3, and the unit for the electric field is Newton per Coulomb. So this is the answer for electric field due to dipole for this distance, for this height, 30 kilometer. So now what we have to do, we have to proceed the same step for the second value, which is Z2, which is equal to 60 kilometer. So we have to replace this 30 kilometer to 60 kilometer. So for B, now Z2 value is 60 kilometer, and I have to substitute the values in the given formula. E, which is equal to 1 over 2 pi epsilon naught Q multiplied by 2h over, which is Z2 cube. So I have to substitute the value, which is equal to 1 over 2 pi epsilon naught. The charge value is 200 coulomb multiplied by 2, and then h value is 6 kilometer. So 6 multiplied 10 to the power of 3 meter. We convert the kilometer to meter. So likewise, the height here is also 60 kilometers, Z value. So 60 multiply 10 to the power of 3, the whole cube. So here I got the answer for the electric field due to dipole is 1.99 multiply 10 power 2 Newton per Coulomb. So this is the answer for two different values of Z1 and Z2. That's it. Thank you.